pre-ACT 2020-21, Passage 4. Passage 4 is another research summary passage. And we can tell that because it says experiment 1 and experiment 2. So when I look at it, that means that our strategy here is to look at our graphs and then jump to the questions. So I've got a colorimeter. I don't need to know what a colorimeter is. If I need to, it will tell me. Light source, vial, detector. Okay, my graphs. It looks like they're all the same. Exposure time is my x-axis, and it's all 0 to 16, 0, 16, 0, 16. Absorbance is all my y-axis, and it's the same scale there as well, 0 to 2, 0 to 2, 0 to 2. Okay, so the one thing that does look different on the graphs, figure 1 is blue food coloring, figure 2 is yellow food coloring, and figure 3 is green. Okay. Question 19. Based on the results of experiment 3, so that means I'm looking at this one, for green food coloring, at which of the following exposure times was the absorbance measured at 427 nanometers closest to the absorbance measured at 603 nanometers? Okay, so that means I'm going to look at my graph. I'm going to look at figure 3, and it looks like the dashed and dotted line is my 603 nanometers, and my diamond line is the 427. So closest would be where they cross, which for time is down here. It's right below 4. If I look, this goes from 0 to 4, so 0, 1, 2, 3, 4. So it looks like each dash is 1 minute, so I'm looking for 3 minutes, and that is B. 20. A student claims that a solution of blue food coloring absorbs light more strongly at 603 nanometers than at 427 nanometers. Is the claim consistent with the results of experiment 1 for an exposure time of 0 minutes? So that means I'm looking at blue food coloring. So I'm looking at figure 1, and I want to go 0 minutes. So which is going to have the higher absorbance, 603 or 427? Absorbs light, so absorbs light more strongly. 603 is much higher than 427. So it looks like this is one of those modeling questions. So no, no, yes, yes. Well, since 603 is higher than 427, my answer to this question is going to be yes. So cross off F and G. Then look at H and J. Yes, because the absorbance was lower at 603 than 427. No, it was not lower. So that means my answer is J. Yes, because the absorbance was higher at 603 than at 427. All right, 21. Which of the following, and this is another one of those graphs, you will at least find one of these on your ACT science portion somewhere. Which of the following graphs best represents the results of experiments 1 through 3 for 427 nanometers? An exposure time of 4 minutes. All right, so let's look at 427. Blue is right close to 0. Yellow at 4 minutes is up here, I don't know, 1.3. And 4 minutes green. Okay, there are 2 lines there. which we're going to get to in a minute. 2 lines at 4 minutes would be, 427. Duh, 427. Okay, that was a duh moment. Sorry, guys. About 0.8. Okay, so it looks like we go 0 for blue. So when I look at blue, this one is definitely not 0. This one is close to 0, not. So just looking at blue, that crosses off all of the other graphs, so it's B. Okay, so I could have just looked at blue and gone from there and got the question done a lot quicker. All right, 22. Which of the following statements about green food coloring is best supported by the results of experiments 1 through 3? Does F, so green food coloring does not react with ozone? Well, there's nothing about ozone in here. Study the effects of ozone on different food colorings. I'm going to go to the next one and see what that one says. It's a mixture of blue and green, or blue and yellow. Well, yes, that I know is true. How do you make green food coloring? You mix green and you mix blue and yellow. Absorbs light at 427, but not at 603. Okay, it absorbs for both of those, so I know it's not that. Absorbs light at 603, but not, so those I can cross off. So I'm going to go with G. And there's no reacting here. If you were to read this passage just to make sure, it's talking about bubbling the ozone through the different liquids, the different food colorings, and so there's no reaction there at all. So that one was just trying to throw you. Okay, 23. Notice these are all the modeling, and so is 20. So this passage had 3 of the 6 questions being the higher, the tougher type of question. 23. Consider the results of experiment 1 at 603 nanometers compared to the concentration of blue food coloring in the solution at exposure time of 2 minutes. The concentration of blue food coloring and an exposure time of 12 minutes. Okay, so it looks like I go lower, so 2 was lower than 12, or higher than 12. So for blue at 603. All right, so it looks like 2 minutes versus 12 minutes. The exposure time of 12 minutes was, okay, lower for 603 and 427. So that means we're going to cross off C and D, which is higher. So lower because the absorbance at 603 was lower at 12 than 2. Yep. Lower because the absorbance at 603 was higher. No, it was lower. So we're going with A. Light at 427 nanometers is violet in color, and light at 603 nanometers is orange in color. Okay, 427 violet, 603 orange. Which of the following conclusions about solution color, light color, and absorbance is best supported by the results of experiments 1 and 2? Okay. Blue solutions tend to absorb violet light. Okay, blue solutions don't absorb at 427. Sorry. Blue solutions, blue, do not absorb at 427. They absorb better at 603. Well, according to this question, violet light is violet at 427 and orange 603. So Let's see. So this one would be violet at 427, orange at 603. If we look at graph 2, yellow food coloring has a higher absorbance at the 427, so that's the violet, lower at the 603 for the orange. Okay, so let's see. So blue solutions tend to absorb violet light more strongly than orange, more strongly than orange. Okay, so violet more strongly than orange, more strongly than orange. No. So we're going to go with less strongly than orange and less strongly than orange light, and yellow solutions tend to absorb violet light less than strongly than orange. No. Okay, so if we look back here at figure 1, 427, less strongly, blue food coloring absorbs less strongly for violet, and blue solutions tend to absorb violet light less strongly than orange light. This would be orange, this is violet. Less strong, according to our absorbent, more strong, 603 is orange, 427 violet, 427 is down here for blue, up here for orange. So that's why it is J. Do you understand why I crossed off more strongly? Blue solutions absorb violet more strongly than orange? No, definitely not. More strongly than orange? No, because orange is up here, violet is down here for blue. So I could automatically cross off those first two and then concentrate on these two. So that gave me J. All right, passage 4.